Hello, ladies and gentlemen. In this episode, we're going to discuss the physics of light. Take a look. You probably noticed that the laser beams didn't move very fast. But according to Einstein, light is supposed to move really fast in vacuum. In fact, a beam of light should be able to travel around the Earth 7 times in less than a second. Now, if you look up the size of the rebel ship, you can estimate that the laser beam propagates with a velocity around 30 meters per second. So this is off by about 7 orders of magnitude. Okay, so 7 orders of magnitude is a pretty big deal. For instance, the difference between $10,000 and $100 billion is, guess what? 7 orders of magnitude. So in terms of net worth, the difference between me and Bill Gates is about 7 orders of magnitude. However, you can slow light in a variety of ways. For instance, electromagnetically induced transparency, or a Bose-Einstein condensate, can be used to slow light, but in that case, the light is not moving in a vacuum. Anyway, that concludes this episode. Thanks for listening. Hello, ladies and gentlemen. In this episode, we're going to discuss the physics of sound. Take a look.
Have you not? What? Yahoo! Look out! You're all clear, kid. Now let's blow this thing and go home.
First of all, what is sound? Well, sound is a vibration that propagates through a medium, such as air or water. In other words, what we perceive as sound in everyday life is really just air molecules oscillating back and forth. So, can you hear anything in vacuum? No, because there is no medium in which the sound wave can propagate. Anyway, that concludes this episode. Thanks for listening. Hello, ladies and gentlemen. In this episode, we're going to discuss the physics of hyperspace travel. Take a look.
Stay sharp. There's two more coming in. They're going to try and cut us off.
Why didn't you outrun them? I thought you said this thing was fast.
Watch your mouth, kid. You're going to find yourself floating home.
We'll be safe enough once we make the jump to hyperspace. Besides, I know a few maneuvers. We'll lose them. Here's where the fun begins.
How long before you can make the jump to light speed?
Take a few moments to get the coordinates from the navigomputer.
You kidding at the rate they're gaining?
Traveling through hyperspace ain't like dust and crops, boy. Without precise calculations, we'd fly right through a star or bounce too close to a supernova and then it'd end your trip real quick, wouldn't it?
What's that flashing?
You're losing your deflector shield.
Both strap yourselves in. I'm going to make the jump to light speed.
So, is it possible to surpass the speed of light? The answer to this question is both yes and no. So, what's the problem? Well, we know that an object with non-zero mass cannot attain the speed of light because you would need an infinite amount of energy. But there is a loophole, because we also know that space is not absolute. In other words, space is something you can twist and bend. So if you can contract the space in front of you, it will be as if you're traveling faster than the speed of light, but you're not traveling at light speed with respect to any frame of reference. You're just moving inside a contracted space. So maybe one day we'll be able to visit distant star systems. Anyway, that concludes this episode. Thanks for listening. Hello, ladies and gentlemen. In this episode, we're going to discuss the physics of the Death Star. Take a look.
Commence primary ignition.
So, is it possible to destroy a planet with a laser? Well, we know that a megawatt laser can destroy a jet from miles away. So, at least in principle, it should be possible to destroy a planet with a laser. However, there is another problem. Notice how the 6 laser beams merge into a single beam? From a physical perspective, there's absolutely no way to make any sense of this. Anyway, that concludes this episode. Thanks for listening. And last, but not least, the episode you've all been waiting for. Take a look.
I've been waiting for you, Obi-Wan. We meet again at last. The circle is now complete. When I left you, I was but the learner. Now I am the master.
Only a master of evil, Darth.
you strike me down, I shall become more powerful than you can possibly imagine.
You should not have come back.
So, are there any problems with lightsabers? Unfortunately, the answer is yes. For instance, lightsabers wouldn't clash. This is because photons only interact with other photons under extremely high energies. In other words, this is something you need a particle accelerator to witness. Now, there are many other problems, and perhaps we can discuss some of them in class. Maybe you can spot one. Anyway, that concludes this episode. Thanks for listening.